Hello, thanks for making it to our talk today. I'd like to present our latest work on a right to repair for mobile apps today, which is motivated by the fact that many countries, including US states and the European Union, are currently debating introducing a right to repair for hardware, like tractors, but don't really consider software, which obviously is getting increasingly important. So we believe this is a timely subject to study. Let's get started. What you see here could be the PhD students at the University of Oxford in their final year. It could also be a metaphor of how human civilization a couple of years back really used to be about finding tools that would enable our survival, and those would get better over time through a process of tinkering and fixing and keeping improving to fit our needs. Fast forward to the 21st century, we have somewhat lost that ability to fix the tools that we use in our daily lives. For example, those of you who have a John Deere tractor will know about the struggle of fixing the latest iterations of them, since John Deere has been locking them down a lot and has been making independent repair very cumbersome. And so a range of states in the US have already introduced legislation against that. Now, going from hardware like tractors to software in the mobile app ecosystem, which is really so widespread these days, there's a really broad range of harms these days, like disinformation, lack of privacy, or accessibility issues. And for many of them, we still don't have a good solution yet. Surely academia will make a contribution to those, but maybe we should have a means to give those most severely affected by these harms an ability to find solutions themselves. And so, taking a bit of a philosophical view, since you probably know that dignity, autonomy, and develop of personality are fundamental legal principles, then might an ability to repair apps, to overcome those harms that are embedded into apps and might significantly affect me, might then such a right to repair apps help protect those principles. Based upon all those observations, we devised two research questions to study in our piece of research. First of all, we looked into the needs for app repair and tried to identify common, pressing, or important needs users have that require modification of their apps. Secondly, we looked into the barriers of doing so, taking a multifaceted approach to that and studying practical, ethical, technical, societal, and legal challenges in doing so. The ultimate aim of the study is not to argue that this technology must be widely adopted, but rather, prior to such a wide adoption, to understand what the risks entailed are, as well as the potential benefits. In the future, legislators may then decide to foresee explicit support for app repair functionality in mobile app ecosystems, since the practical implementation of them still remains difficult due to limitations imposed by Google and Apple in their respective app ecosystems. To study these highly interdisciplinary research questions, we opted for a mix of various methods. You could also say we just threw everything that we had at these research questions so as to really get fine-grained, nuanced, informed results. This involved a survey with 100 participants asking them what they'd like to change, why, and how they feel about app repair in general. This included a prototype, a technical prototype, and a couple of case studies to understand the feasibility of the approach, as well as practical and legal challenges. And lastly, we conducted 8 expert interviews to be able to conduct a detailed and nuanced ethical and legal analysis of app repair. The main part of our survey was asking 100 participants about what they'd like to change about the apps that they regularly use. The participants across all of them, came up with 700 suggestions as to what to change. We excluded 150 of these suggestions from our thematic analysis because these suggestions were either not actionable or relevant for app repair. Among the remaining suggestions, we identified three categories of actionable and relevant app changes. Firstly, users expressed the wish to make apps' business models more user-friendly and respectful. For example, reducing highly engaging elements in apps, or being annoyed by the amount of ads that they see in the YouTube app. That was a very common concern. Secondly, there was a wish for more attractive, user-friendly, accessible user interfaces. For example, one participant expressed the wish to make an app more suitable for educational settings and made suggestions as to how to accomplish that. Lastly, a common concern were privacy and security issues in apps, both in relation to companies as well as in relation to other users. We now turn to our technical prototype. This is slightly different to what we present in the paper because we've evolved it a bit, but the idea is the same. In the first step, the user would select the app that they want to make a modification to, for example, the Twitter app in this example. In the second step then, the user selects from a range of pre-installed modifications to the app. Those are developed by so-called patch developers, who are similar to browser extension developers on the web, experts in programming who sort of have crafted these patches. And in the last step, these modifications then get applied to the app and the user reinstalls the modified app on their phone. As a result of the process we saw just now, end users with the Greasejoy tool can remove distracting elements from the Twitter app, like the stories bar at the top or annoying notifications that cannot currently be disabled in the Twitter application. We also conducted 4 other prototypes. If you're interested in those, please refer to our paper. And based upon those prototypes, we made a couple of observations. First of all, we found that making changes to the user interface of existing Android apps is pretty straightforward if one has previously worked with Android app development, because the approach is the same. Secondly, we find that making changes to the underlying code of apps requires sophisticated programming skills. These might be available in computer science academia, but outside of technical disciplines, it is probably very hard to, say, run a study with participants based upon app repair technology to, say, study the impacts of certain design patterns in apps on individuals. So this is clearly some space that should be improved in future work. Lastly, we worked with a couple of legal experts to understand the legal implications of such a tool, and we do see some concerns outside of research settings when it comes to the use of app repair functionality. However, we see that once a legislator would establish clear obligations on providers of software to foresee app repair functionality, then these should be mitigated. So maybe this is just some legal vacuum that still needs to be addressed. Based upon all the evidence we gathered in our paper and an additional 8 expert interviews, we then do a very in-depth ethical analysis of app repair, talking about the benefits and opportunities, as well as the risks and challenges in such a design. The reviewers really liked this part of the paper, but it would be too much for this talk to go into that now. Yet, if you're interested, I encourage you to just have a look at our paper. This is it from me from now. If you're interested to hear more, feel free to reach out or to ask questions. Thanks so much.